about simplifying radicals. Copy everything I copied, and make sure you stop and ask any questions as soon as you have them. So first thing we'll do is talk about some vocabulary terms. First thing we'll do is talk about some vocabulary terms. So to do that, I'm going to give you an example. Square root of, let's put 4 here, 25, and a 1. Now, this symbol right here is called a radical. Sometimes it has different names, but it can always be called a radical. This symbol right here that I made darker, the square root of these things. Now, that number 4, whatever number goes in this little V spot, and it's a little number, is called the root. Another word for root is index. So that can be called the index or the root. Fourth root, fourth index. Now the number inside of the radical is called the radicand. And then this one you're all familiar with. This is an exponent. So make sure you copy it down. If you have any questions, just ask. Now, right below this, I'm going to give you some more information. This is called the square root. Now, I know this is called a radical according to our notes before, but this specific radical is called the square root because of the index. The index on a square root, if you don't see a number in there, you have to assume it's a 2, because square means 2 exponent. So, little food for thought here, the index will never be smaller than 2. The index has to be 2 or more. So if you don't see nothing in there, it's a 2. If you see a number, it's that number you're looking at. So now we can talk about the opposite of a square root. The opposite of a square root is a square. And a square just means a 2 exponent. So a square root means a 2 root. A square means a 2 exponent. Now let's do the same thing, but with a 3. If there's a 3 inside of the radical, we call that a cubic root. And a cube is a 3 exponent. Alright, next page. Now, let's say you have x to the second power equals 16. Is x by itself? X is not by itself. There's a square on it. Now we go to our notes. What's the opposite of a square? A square root. Why is that the opposite of the square? Because there's a 2 root. A 2 root is the opposite of a 2 exponent. So it would cancel and bring your x down by itself. But whatever you do to the left side, you also have to do to the right side. So since we put a square root on the left side, we put a square root on the right. And now square root of 16 is positive or negative 4. Now why is there 2 answers? Because positive 4 times positive 4 is positive 16, but negative 4 times negative 4 is also positive 16. So that shows you whenever there's a square root, there's 2 possible answers, the positive and the negative version. So for the working here for this chapter, I only want the positive one. You don't have to give me both. So if you just tell me square root of 16 is 4, that's good. So I just showed you how to cancel a square by using a square root. Now let me show you how to cancel a square root by using a square. Square root of x equals 10. Now, is there a x by itself here? No, there's a square root on it. What's the opposite of a square root? A square. A 2 exponent. Opposite of a 2 in the root is a 2 in the exponent. Now what that will do is cancel and bring x down by itself, exactly what we want. But whatever you do to the left side, you also have to do it to the right side. 10 to the second power means 10 times 10, which is 100. You could also use common sense. Square root of what would be 10? Square root of 100 would be 10. Now let's do the same kind of examples. But for cubes. So x to the 3rd power equals 8. Now what's the opposite of a 3 exponent, a cube? A cubic root. This cancels the 3 exponent and the root, brings x down by itself. But whatever you do to the left side, you have to do to the right side. And what we did was put a cubic root on it. Now, cubic root is similar to the square root. The square root is a number times itself. 2 times only. 7 times 7, 49. A cubic root is the same thing, but it has to be 3 times. So, what times what would be 8? 2 times 2 times 2 is 8. So the cubic root of 8 is 2. Now let's do it the other way around. Cubic root of what would be 3? Now, x is not by itself. How do we get an x by itself that has a cubic root on it? Adding 3 exponent, the opposite of the cubic root. If you do it to the left side, you do it to the right side, and we get x equals 3 to the 3rd power means 3 times 3 times 3, which is 27. Copy everything down. Alright, now we get to the actual lesson. What I just showed you right now is like an introduction to this lesson. What you just saw being done is not what you're going to have to do on the lesson. or on the EOC. That's just to give you an understanding of what we're doing here, right? But what we're actually going to do is very simple. So let me explain something to you first with numbers that are perfect squares, and then we'll simplify non-perfect squares, because that's what you're going to do here, simplify non-perfect squares. So watch, let's say we have square root of 25. What is the square root of 25? What number multiplied by itself gives you 25? 5. So you know that the square root of 25 is 5. But the big question is, why? Why did that square root of 25 now turn into a 5? Why meaning why mathematically? And why mathematically does that make sense? And I'm about to show you. Now 25 can be broken down to be what times what? 5 times 5. Right? Now any number multiplied by itself can be written as a square, correct? And you have a square root on it. What happens to the square now that there's a square root on it? What's the opposite of a square root? A square. So it cancels and it equals 5. This is why. Now you see how we wrote this with a square? You're not going to do that in this lesson. This is how to understand it. Now how I'm going to do the next problem is how you're going to do every problem on this lesson. So here's the first example. Square root of 16. Square root of 16 can be broken down to be 4 times 4. Now what's the root? If we don't see a number here, what's the root? That's not a root. A root goes in this little spot right here. If you don't see a number there, what's the root? A 2. That's the key. So everybody pay attention to this part. That root tells you how many times something has to repeat to come out of the radical once. So is there anything else left here? No. So since the 4 repeats twice, it comes out once, the answer is 4. Isn't the square root of 16 4? Yes, it is. So square root of 16. Watch me do it a different way. I chose 4 times 4 on purpose to choose numbers that repeat. Because what you're doing here is pulling out numbers that repeat. But on this one, let's say you forgot that rule and you decided to use 2 times 8. Can 2 be broken down more? No, so it comes down. Can 8 be broken down? 2 times what is 8? 4. Can 4 be broken down more? 2 times 2. This one comes down, this one comes down. Now, does anything repeat twice? The 2 repeats twice, it comes out once. Another 2 repeats twice, it comes out once. If more than one number come out, you multiply them. What's 2 times 2? 4. Same answer. So, it doesn't matter how you break it down, but look at the amount of work we did here and the amount of work we did here. 1 step here, 4 steps here. So that tells you always try to use numbers that repeat themselves. So use that common sense. What I just said, use that common sense to do the next one on your own. Square root of 100. Now I know the answer is 10, but I want you to break it down, circle whatever repeats twice, and take it out once. Try square root of 100, then try square root of 200. Both on your own. So what two numbers did you choose to break down the 100? Catherine? 10 times 10. Those are the numbers that you should be using because they're the same number. If anything repeats twice, it comes out of the radical once. Is there anything that's in there? No. So it comes out once, and that's the answer. You can always verify. Is the square root of 110? Yes, it is. Now let's do square root of 200. Square root of 200. 2 times 100 would be 200. Can 2 be broken down more? No, so it just comes down. 100 can be broken down to be 10 times 10. Now, I know they can be broken down more, but what's the point if they already repeat? If something repeats twice, it comes out once. What stayed inside of that radical? What did we not take out? What did we not take out from here? The 2. So that's my answer. Square root of 200 is 10 square root of 2. Now I'm going to drop the numbers lower and let you practice. I'm going to show you one, let you practice. So let's go with square root of 20. And let's go with square root of 18. I'm going to do the first one for you. 20 breaks down to be 5 times 4. Can anything be broken down more? The 4 could be broken down to 2 times 2. This 5 comes down. You can always check if you did it right by multiplying these 3 numbers, making sure it gives you 20. 5 times 2 times 2 is 20. Now, does anything repeat twice? Because the 2 repeats twice, and that's the root of 2. That's why we're looking at that 2. It comes out once. What stayed inside of the radical here? The 5. So 2 square root of 5. Now let me teach you a trick. How many times did this 2 repeat for you to be able to take it out there? Twice. So if you ever want to check your answer, 2 times 2 times 5, 20. I did it right. So work it out backwards. 3, let's say 3 square root of 9. That would be 3 times 3, which is 9 times 9, 81. So that's just how you work it backwards to check your answer out. Now we're not going to work it backwards. We're going to continue to practice. So I want you to break down 18, get an answer, and then I'll review it. Some of you are going to use 6 times 3 for 18. The smarter ones are going to use 9 times 2 because 9 is a perfect square and it's going to make numbers repeat. Good. I got you. I got one for you. Do it on the board. Square root of 3 million.
Yeah, no, that's gonna be a lot. The square root of 3 million?
Don't be scared. Don't be scared. After this one, I'll show everyone the millions so you can see how easy the millions are.
3 million, 3 times.
You'll see.
Right.
Trust me.
And you trust me with the other problems that we had in the.
But you see, you don't know everything, right? So I'm here for you.
Can I ask you about those earphones from?
Because the gamer ones, because people can't hear people listening.
Oh,
Go. Live.
move. Got it.
All right. David, after this question, I'm going to do the million one. You want to peek through the window.
I'll come by.
All right. So 18. 9 times 2 is 18. Now, I know 9 is a perfect square. It's going to give me 3 times 3. Bring this 2 down. Now, since the 3 repeats twice, it comes out once. What stayed in there? The 2. Done. If you want to check your answer out, 3 times 3 is 9 times 2, 18. Now, I want everyone to pay attention to this because people get scared when they see large numbers. And I don't want you guys to be scared. So watch. Square root of 2 million. Now Robert, after I explain this, you're going to be able to tell me what the square root of 3 million is, what the square root of 5 million, 6 million, 7, all of those, without doing any work. All because you did this one first. So watch. Yeah, this is 2 million, but to me, it's a 2. 2 times what is 2? 2 times 1. How many zeros are there? 6 of them. So let's put 3 on this side, 3 on that side. So now we turn that 2 million into 2,000 times 1,000. Now, don't touch the 1,000. Do not touch the 1,000. The point is to get a number to repeat. So let's turn 2,000 into 2 times 1,000. Bring this 1,000 down. Does anything repeat twice? The 1,000 repeats twice. It comes out once. What's still in the radical? 2. So square root of 2 million is 1,000 square root of 2. What's the square root of 3 million? 1,000 square root of 3. What's the square root of 5 million? 1,000 square root of 5. What's the square root of 6 million? 1,000 square root of 6. You see how it works out just because you did 1? Right? People always tell me that, Mister, I'm getting good at this lesson. Because this lesson, you get good at it quick. And I go, okay, do 3 million. Oh, that's too hard. Once I show them one problem, they tell me, Mister, I'm never going to get a million question wrong. I know it. Every single one of them, you get it right. So, now, square root of, well, let's say 2 square root of 30. This is the next example that we're going to do. Now, over here, this is just like saying 2x. When you have a letter next to a number, that means multiplication. Same thing here. This would be 2 times square root of 30. When you say it, you just say 2 square root of 30, just like when you say 2x, you just say 2x. You don't say 2 times x. So same concept. It's still multiplication. So why is that important? You'll see now. We break down 30. 30 is 2 times 15. Right? Now 15 breaks down to 3 times 5. Does anything repeat twice? If nothing repeats twice, this is already simplified. So the answer is 2 square root of 30. It doesn't change. So what do you learn from that? That if there's more than one number that are still in the radical, what do you do with the final answer? Multiply them, and that's your final answer in there. Don't leave it as 2 times 3 times 5. If numbers stay inside, they get multiplied. If numbers get pulled out, they get multiplied. So now let's do one where you're going to have to pull out a number. 3 square root of 16. 16 is 4 times 4. Since the 4 repeats twice, it comes out once. There's nothing else left in there. So my answer is what I pulled out and what was already out there. If there's already a number out there, multiply it. So 4 times 3, 12. Now let's use common sense. 3 square root of 16 means 3 times square root of 16. The square root of 16 is 4. So really this is 3 times 4, which is 12 anyways. So I'm going to put one on the board, let you try it on your own. You're going to try 5 square root of 45 on your own. While I teach David. Good. Let's see, you got square root of So 2 million, right? Don't even look at the million. 2 is 2 times 1.
Of course.
Right?
Of course.
And now, since there's 6 zeros,
It's 2 square root of 1 million.
split them up. Be quiet. Stop. You're getting it wrong because you're
Yeah.
jumping ahead for some reason.
I'm just thinking.
Look, don't think. Just watch. Learn. 2 times 1, since there's 6 zeros, put 3 on each side.
Okay.
Now, don't touch the 1,000.
Use that one.
2,000 is 2 times 1,000. Now, since it repeats twice,
That's
it comes out.
square root 1,000 square root of 2.
Exactly. So now that you know what the answer to this one is, what's the square root of 3 million?
What is it? 1,000 square root of 3.
Square root of 5 million.
1,000 square root of 5.
What, and then this one?
Yes. I don't know if I can do that.
You know, this is being recorded.
Well, you might not get a response.
Yeah. Square root, that would be, yeah, I'm not even doing it at all. I just don't want it on this one because this is, I'm recording this so I can
Is
put
it?
it
Oh,
on
she's
sheet.
following me. Camera's following me.
What?
The camera's following me.
That's okay, it's okay. They see the screen, don't worry.
They don't see that.
They see the screen, yeah. No, they see you in a little silhouette like that, and I have no problem them watching you work that out.
Yeah. Oh, so, okay, why is this 8?
Hmm?
Why is this one 8?
Solve it, and don't get it wrong.
I was trying to write it down.
Somebody taped it to trick me. Throw it out.
All of
That's Khan. That's Khan. That has Khan's name written all over it. Khan taped off when marker comes. So, Robert. So, I know you already worked it out, right? But this is what's going to happen when you do this lesson, all right? I wish I was actually looking at you, but I feel bad.
Right.
Then with this lesson, the more you learn, right? The more, same thing with exponents, the more you're going to be able to do in your head. I want you to show work, but watch this. 45 is what times what?
I'm confused.
Robert. All right, look. The more you learn in this section, the less work you have to show. Kind of like exponents. On this lesson, I do need to see all the work, but let's test, like, let's say you haven't done this problem, right? 45 is what times what? All right, 9 times 5. And you know 9 is a perfect square, which is going to be 3 times 3, right? So what's going to happen in your head? We're going to pull out a 3, and there's going to be a 5 left inside, right? So if you pull out a 3, and there's a 5 there already, you multiply that. And what was left inside? 5. So why do I say that? Let's say square root of 28. Don't do it on a paper. Everyone put your pencils down. What times what is 28? 7 times what? 7 times 4. Is 4 a perfect square? What times what is 4? 2 times 2. Which means a 2 is going to come out, and what's going to be left in there? Seven. You understand? So, yeah, I want to see 4 times 7, 2 times 2 times 7. I want to see you circle the 2, pull it out. That's the work I want to see. But really, you could do it in your head, right? 3 square root of 100, right? That's going to be 3 times 10, 30. How do I know? The square root of 100 is 10. 3 times 10, 30. Now let's take the next step. The next step is a radical times a radical. Now, the way the book shows you this is anything multiplied by itself can be written as a square. The square cancels the square root. The answer is 7. Right? That's the way the book teaches it. But we're going to do it the way we just learned how to do every other problem. Watch this. A radical A radical times a radical, put them in the same radical. Does anything repeat twice? The 7 repeats twice, it comes out once. Nothing else is left in there, so my answer is 7. Wasn't my answer 7 when I did it the book way? Same thing, but it's easier just to look for 2 numbers to repeat and pull it out one time. Now, with your pencils down, what's the square root of 6 times the square root of 6? 6. Why? Because the square root of 6 times the square root of 6 is going to be the square root of 6 times 6. Repeats, comes out. Does that make sense? Now, how about square root of 49 times square root of 36? Now, a radical times a radical, put them in the same radical. Now, some people last year, when I taught them to do this, they multiplied these numbers and got like a number in the thousands. What is the point of that? Isn't the point of this whole lesson to break things down? You break it down. You don't build the number back up. So right here where you see them, break them down. 49 is 7 times 7. 36 is 6 times 6. The 7 repeats, it comes out once. The 6 repeats, it comes out once. If there's more than one number that got pulled out, multiply that. 7 times 6 equals about 42, man. You understand what I'm saying? The point of teaching you that, showing you that problem is to show you, do not build these 2 numbers back up to a big old number. The point of this lesson is to break it down. So keep breaking it down. Now, 3 square root of 3 times 4 square root of 6. Let's do this example. Now, these numbers outside follow regular number rules. 3 times 4 is 12. But as far as the radicals go, a radical times a radical, put them in the same radical. Now, 3 comes down, but 6 could be broken down to be 3 times 2. Since the 3 repeats twice, and that's the root, the 3 comes out once. What stayed inside of that radical? A 2. You with me? But now look, you pulled out a 3, but there was already a 12 out there. If there's more than one number out, what do you do with them? Multiply them. So the answer is 36 square root of 2. Alright, next step, square root of 40 x to the 7. Now we throw variables in there. Now watch, the variables do not change the process. The process is exactly the same. 40 is going to get broken down to 4 times 10. 4 breaks down to 2 times 2. 10 breaks down to 2 times 5. So right now we have 2 times 2 times 2 times 5, which is 40. But you're missing the letters. How many x's do we have there? 7. 7. So 1, 2, 3, 4, 5, 6, 7. Now we're going to do the same thing. Circle them 2 at a time because the root is 2. So the 2 repeats, it comes out once. 1 set of x's, 2 sets of x's. 3 sets of x's. You with me? Does anything else repeat twice? So my answer is going to be what I pulled out, which is 2x to the 3rd power, 3 x's, and what stayed in the radical? 2 times 5, which is 10, and that little x at the end. Don't worry, we're going to do a few practices. So try this on your own. Square root of 16x to the 6. So some of you should be able to give me that answer without showing any work whatsoever. Alright, let's see. 16 breaks down to be 4 times 4. I know they give you broken down more, but there's no point in doing that because it already repeats twice. Now, we also have 6 x's. So, since the 4 repeats twice, it comes out once. We have 1, 2, and 3 sets of x's. So it's x to the third. There's nothing else left in there, so the answer is 4x to the third. So, let's do an example here. Let's do an example here to test out our knowledge on what we're actually doing here. Square root of x to the 100. Are you going to draw 100 x's? Because if you are, don't do it. Right? If there was 6 x's, how many do we take out? 3. Because you can only circle them 2 at a time. So if I'm circling them 2 at a time, on 100, how many am I going to come out with? Huh? 10 if I'm circling them 10 at a time. But I'm circling them 2 at a time. If I put 4, 5, 6, 7, 8, 9, 10. If I put this 10 times and do 100 of them, and I go 1, 2, 3, 4, 5, 6, like that. How many am I going to get to? How many pairs? How many pairs? Huh? 10 pairs? I already have 5 pairs with 10 only, and I got 100 of them. 50. Because you're dividing them by 2. You can only circle 2 at a time. So this would be x to the 50 power. You with me? So what's square root of x to the 200? X to the 100. Does that make sense? Now, don't let me trick you. Square root of x to the 101. I know you got this in you there, Alexander. You got the understanding right now to get this right. Don't worry. Think about it. This one gave you 50 x's because it was 100. This is going to be 101. So what is my answer going to look like at the end?
X 51, right?
What?
X 51.
X51 would be 102. We didn't make it. It can't be 51.
1x3
Okay, 1x, like 1x 50, now what?
25.
Huh?
25.
No. Think about it. If I circle 50 sets, how many are left over here? 1. So what's inside of the radical? 1x. You get it? So like x to the 17th. Square root of x to the 17th. Divide that by 2, you're going to get x to the 8th power, but that will be only 16. There's 1 left over. Does that make sense? So the letters doesn't change it. Alright, little activity real quick. Square root of, let's see who can get the answer quickest here. Square root of Cáceres. Square root of Cáceres. Solve it. Tom did a funny one this morning. Square root of Cáceres. Who's going to be able to do that one with all these variables? You think you got it? Do it. Wait, don't come on. Don't come on. That's correct. But whatever you cancel doesn't cancel. It comes out of here. There you go. First time you get the church one right? Let's go. That's correct. These are the notes I look at when I'm teaching you whatever. Just a couple lines to like remind me what I gotta cover next. So like, example, 4 root of 25 just to give the vocabulary. So I don't actually write all my words down, but I know them. I just need to like follow what God is. Exactly. Right. Don't worry about that. Alright. So, square root of Cáceres. Does anything repeat twice? The C repeats twice, it comes out once. The E repeats twice, it comes out once. Nothing else repeats twice. So my answer is CE, square root of R's. You with me? Now, why, before I give you another tricky one, why am I looking for it to repeat twice to put it out once? Why is it a 2? Because it's a square root. Very good. Now use that common sense to do square root or cubic root of 16. How many times do they have to repeat here? 3 times. So keep that in mind. Yes, but don't change the root, so put a little 3 in there still. Perfect. So 16 is 8 times 2. But 8 breaks down to be 4 times 2. This one comes down. And 4 breaks down to be 2 times 2. So we have 4 2's down there. Since the root is a 3, if it repeats 3 times, it comes out once. Now the root is still a 3 in there. What's left in the cubic root? Just that 2. So try this one. Cubic root of 27. Alright, 27 is 9 times 3. 9 gets broken down to 3 times 3. This 3 gets pulled down. Now, does anything repeat 3 times? Yes, it does. If the 3 repeats 3 times, it comes out 1 time. Since there's nothing else left here, you know that the cubic root of 27 is 3. Last one. Cubic root of 128. It's a little bit harder one, but it's the same process. I want to see you do it without making a mistake along the way. So break it down. My opinion, when you get big numbers, always divide it by 2 or by 3 at first. So make this a 2 times a 64. 64 is a number you can work with. Why not? You got it?
I'm working
Like, this is one that I know off the top of my head. I know the answer already. Just because of what this number is. Obviously, I'm a teacher. I've been practicing these multiples and factors for a while. But I know that 64 is 4 times 4 times 4. So 16 times 4 is 64. So already I know that I'm going to pull out a 4. If I pull out a 4, the only number left in there is 2. So my answer has to be that simple. So let's break it down here. Remember, when the numbers get large, break it down by dividing it by 2. So 2 times 64. Now this is a number you can work with. 64 is 4 times 16. And 16 is 4 times 4. Bring down this 4, bring down this 2. Now, does anything repeat 3 times? Because the root is 3, it's got to repeat 3 times. Since it repeats 3 times, it comes out once. Now, what's still in there? What do we not pull out? The 2. So that would be 4 cubic root of 2. This number could go up to any number, and that's just the amount of times you have to repeat to put it out once. You got it? So I'm going to put the class to work on Google Classroom. Try a couple things. It says 2 through 20 even on it. Don't do all. Alright?